Hi, I'm Jody from Geeking with Jody, and I want to talk about Linux as a virtualization guest. The way it is one, it's not very in-depth, and it needs you to understand concepts of virtual machines, understanding IaaS, infrastructure as a service, understand unique properties of a Linux system. This is important part. Also, Linux images, how to deploy Linux on the virtual machines, and these kind of stuff. Awareness of cloud init. I won't forget it. Also, following the partial list of used file terms and utilities are these ones: virtual machines, Linux containers, application container, guest drivers, SSH host keys, dbus machine IDs. But let's start and discuss what is the virtual machine. As any other virtual things, virtual machines are not physical. So normally you might have a laptop, physical laptop, and install your Linux on it. Not sure you install it on your keyboard or on your monitor or on your hard disk. So this is better. Imagine you have your laptop, this is the hard disk, and you install your Linux on this machine. But when we are saying about virtual machine, it means there is no physical machine there. You are using a software to emulate or simulate a computer, and you install your virtual machine inside that simulated computing environment. This software is called Hypervisor, or it might call Virtual Machine Manager. A very famous one is VirtualBox. For example, here I have a Windows machine here. This is a Windows machine. You can see from here. I have the Oracle VM VirtualBox installed. I run this software. Then I create a virtual machine here. These are each are one virtual machines. And when you run one of these, you will get a window here. I mean, this window, which is a separated virtual machine. It doesn't need to be a window. On a default VirtualBox, it creates a window because it's a graphical machine. But this is an environment with a virtualized CPU. So it's an imaginary CPU, simulated CPU with some simulated hard disk and some simulated RAM. For sure, this simulated RAM practically writes in the main RAM, but with the hypervisors supervision. This virtual CPU, at the end, the commands are being run on the main CPU of the machine, but with the management of the hypervisor, which is a VirtualBox here. And this HDD at the end might be a file on the main hard disk, but these are all simulated. So this is what a virtual machine is. Here we see it because it's graphical. It might not be graphical and you may not see a window. To check and see if your host operating system, here my Windows, can provide virtualization. If it's Linux, I should check the properties or flags of the CPU and see if I have VMX or SVM. I'm using Windows, so I don't have that command. I will run it inside my virtualized Linux. This is a virtual machine running Linux. This is called the host OS. This is called the guest OS. Now I have a Fedora as a guest inside my Windows host. So on my guest machine, which is a virtualized environment, I can check the proc CPU info, which shows CPU information. It says you have some CPUs. Here I think I have only one. So processor number 0, the first one, has some flags. This doesn't have VMX, which is needed for virtualization, but it has one hypervisor. It has a hypervisor flag, and this tells to the machine that this is a virtualized environment. This is not a real machine. If this was a real machine capable of having virtual machines inside it, I would have VMX or SVM for AMD and for Intel CPUs. Please note, sometimes this functionality is disabled inside your BIOS or UEFI configs. You have to go to your BIOS or UEFI and enable the hypervisor capability. Okay, and on Linux machines, KVM inside the kernel handles, or KVM AMD handles the virtualization on some hypervisor level. I will talk about it in a minute. But you can check if you have KVM or not by checking your modules. We had this in previous sections. Also, we had this command, just not to forget it, ls CPU. You can say ls my CPU and it will show you the configurations of the CPU. But let's speak about this hypervisor in more depth. We have two types of hypervisors. As you can guess, type 1 and type 2. But as you cannot guess, I will start by describing type 2, which is easier. You have your hardware here, which is my Windows machine. It's not a Windows machine yet. It's only an IBM hardware. I install an operating system on this. In my case, this is Windows. On my Windows, I install a hypervisor, in my case, VirtualBox. In that VirtualBox, I installed a Fedora Linux. Okay, this is type 2, called hosted, because Windows is hosting Fedora. I were able to install other hypervisors too. I could install VMware here and install an Debian in my VMware or another Windows on my VMware. At the end, this is hosted because I have my hardware, I have an operating system on that hardware, and then I had hypervisor installed on this operating system, and then I had an virtualized machine here. This is type 2. But on type 1, which is called bare metal or native, you have your hardware here and your hypervisor runs directly on your hardware, and then you can install your operating systems here. You don't need an operating system on your hardware. Your hypervisor directly runs on the hardware. This is more advanced, but in most cases you will see type 2. Even on large businesses, you will see, for example, VMware running on an operating system. Okay. Samples of type 2 are VirtualBox and VMware. Samples of hypervisor type 1 are KVM, which presents in Linux kernel, on all recent Linux kernel after 2.6, which is ancient. Another sample is Zen. You can search and see you have Zen kernels which you can install, or Hyper-V or Hyper-5s. But how we can create virtual machines? You might have seen the most simple one. You create a new virtual machine here, then you provide it an ISO file of one operating system. For example, here I create a new one when I wanted to create this Fedora 36. You saw how we started our lab. We created a new virtual machine. We provided it with the ISO file or CD or DVD of an operating system, which was Fedora, and installed it. This was the most simple one. But what happens if we want to have 10 of this specific machine? That would be very difficult to install it for 10 times. So we can clone it, just the way people clone. Because this is running, I cannot clone it. But for example, this is a Debian machine, I can clone it. I will clone this machine into another one and we'll have an exact copy of it. Another method is exporting the virtual machine I have to an OVF format, Open Virtualization Format, and import it into any hypervisor which understands OVF format. OVF might give you different files, like configurations of the different machine, hard disk configuration, and etc. So there is another one which is called open virtualization archive. This is an archive, so you will have only one file, including all the files here. It is also possible to have templates. On more professional environments, they have templates for example, Ubuntu version blah blah. They have a template for a web server based on blah blah. When you install the template, it's like cloning with some more configurations and it's cleaner. But we have a problem here. When you clone a machine, or even sometimes when you create from a template, some things are cloned or copied, and they may create problems. The most obvious one is the NIC, Network Interface Controller, or network cards MAC address. You cannot have duplicate MAC addresses on your network. So if I just simply go here and clone this machine, this will clone the whole thing. So I will have the same MAC address for both machines. Before starting that machine, I have to edit that, or I have to move it to a separated area, or disconnect all the network, start it to change the configurations, and then run it live on the network. You should change the host name of the machine, the MAC address of the network card, the IP address if it's not using DHCP. Also, one important thing is your machine ID on your D-bus. Each machine has a unique ID. You have an ID, which is an ID. You can have a unique ID. You can have a universal unique ID. So you will see UUID in many areas. Universal unique ID. It's a very long random combination. To give your machine a new unique ID, you should delete etc machine ID, delete var lib dbus machine ID. Sometimes these are linked to each other, and then run dbus UUID generator with the ensure switch to ensure that this is unique. This way, dbus will have a unique ID for your machine. Also, there will be some encryption keys maybe in .ssh directory. It is good to delete them or change them on the machines. Also, hard disk might have UUIDs or any other UUID you see. Also, on some templates, there are some placeholders which should be edited. In most cases, when you create templates, there is a documentation which says, okay, if you are creating from this template, change these to the proper values. Also, one more important thing is this is a virtual machine. So technically, this is a computer which is running. This might need some specific drivers. Those should be installed inside your guest OS. This is the guest OS. I have a guest Linux. I might need to install some additional drivers or additional programs. For example, on VirtualBox, you can go to the device, and from device, if you say install guest additions CD image, it looks like that you have inserted an image into this computer, CD image. Then you should go to your CD drive, run the install program, and on VirtualBox, for example, it will install the graphical drivers, and you can maximize your windows. On a VMware, there are some additional tools your system admin may give them to you and say, okay, please install this inside your machine. When you install them, the VMware software will be able to speak with that VMware agent you've just installed in. This is on the host machine. This is on your guest machine. So the VMware on the host machine will be able to talk with VMware agent you installed on your guest, and using that, it would properly be able to, for example, shut down your machine, would be able to read statistics about your machine, check your status, and these kind of stuff. So this is something more you should have in mind. On the last part, before the IaaS, let me speak about containers. Up to now, I showed you virtual machines. On your hardware, you were installing a hypervisor using a host OS in type 2 or without a host OS on type 1, and there you had a complete machine where you could install an guest operating system, then the libraries you need, and run your apps. This is a virtual machine. Another idea or method which is more modern is containers. When using containers on your hardware, you run the host OS, then you run a container engine. You don't need the guest operating system anymore. On your container engine, you run whatever binary and library you want, and you run your apps. Your apps will use this. If needs something from the operating system, instead of using the virtualized operating system, it will use your main operating system. This is cleaner, less overhead on your operating system. Also, you have good things. For example, the idea comes from the trucks and their containers. You have a web server, for example. You don't need the whole operating system to put your web server on it. You just need the libraries needed by that web server and your data. So you put them in one container and run them on your host operating system. This is the operating system of the host, for example, the truck. If you have more capacity, you can just create another container and run it there. If this crashes, it's isolated from the operating system or other containers. So nothing bad will happen. If you want to have elasticity and increase the capacity in case you have more customers, you can just configure your operating system to run, or your container engine to run more and more of these containers when new users come, or even run them on other host machines, same container. It's very clean. Or if you are writing a software, you don't need to bother about what libraries the host operating system is providing. You say, okay, I need this app with these libraries inside a container, and your container will run them. Even it's possible to run kind of whole operating system inside the container. So that way you can test things before upgrading your host OS, for example. Different ideas, and it helps a lot. It's good to have an idea. But in general, it's a combination of the programs you only need for your specific need without the whole operating system. So this is how containers works. And the last thing which we need to discuss is IaaS, infrastructure as a service. In the old times, you would have your own internet connection, your own hardware, your own power to run your host. Later, you just needed a server. You would put your server in someone else's place, use their internet, use their hardware, their cooling system, and they were running your hardware. Nowadays, you just go to a website and say, okay, hello cloud service provider. Please give me a Debian machine. And your Debian machine is running here without you knowing anything about its hardware, even if it's in European country, in US, or any other place. Even you may have, for example, your server in US and you want to move it to Asia. With one click, you can say, run my new machine in Asia. Move my old machine to Asia. Copy this another one to in Africa, or whatever you want to do. You are using a cloud service provider which gives you the infrastructure like power, like networking, like databases, like hard disk as a service. When you have a computer virtualized running inside a cloud service provider, for example, AWS, Amazon Web Service, you can say, oh, I need some more hard. From your panel, you will go and say, I need some block storage. I want 2 gigabytes of block storage. It will give it to you. Connect this to this one. I need a new networking interface. Please connect it to this machine. All of these are happening as a service. You don't manage this infrastructure. So this is called IaaS. You can have load balancers. Tell them, I have these 5 servers. I need an IP which balances my load on these machines. First this one, then this one, then this one. Or send the new request to the machine who answers faster last time, for example. Or you can have object storages. When you have an object storage, you are not managing the hard disks anymore. I mean, even the virtual hard disk block storages. You are telling the system, I have some files for you. Please save this file. It will tell you, okay, I saved this. This is the unique ID of this file. Whenever you want, you just give another call and say, I want the file with this unique ID. It will give you back the file. Or manage databases or different ideas and things. Some of the famous ones are Amazon Web Services, Google Cloud Platform, Microsoft Azure. And there is a command, comes from Ubuntu, Canonical. That's why I believe they said, okay, please add this to the LPIC. It is Cloud Init. It helps you initialize cloud instances from your command line with some configs. You can say, I need a new machine on AWS with blah blah configuration, or on DigitalOcean, or on Azure. This is Cloud Init command. I believe you know whatever you needed, and that's it. Have fun. Sorry that this was a kind of pure theoretical, but from here we will go super duper hands-on. The next part is about the Linux commands.